Hey
Hey,
everyone, it's STEM time with Navya and Aishwarya. We are your hosts, Navya.
and Aishwarya. Following the theme of the last couple weeks, for today's episode, we are going to be doing an extension once again to Amazing Abstractions, and it's going to be a part three. So, we want to help you guys master everything there is to know about abstractions. So, we are going to help increase your knowledge about abstractions at a more advanced level by introducing some new topics today. But before we dive in, Navya is going to give you guys a quick update on the current event for today's episode.
So the current event for today's episode it isn't that recent, but it is really interesting, so I included it. On May 26th, researchers at the National Institute of Standards and Technology have developed a mathematical formula that computer simulations suggest that could help 5G and other wireless networks select and share communications frequencies about 5,000 times more efficiently than trial and error methods.
Great. Let's go over the agenda for today. The questions we will be addressing include: what is data abstraction?
What are the parts of abstract data types?
What is the sequencing abstract data type, and what are the operations?
What are mutable data abstractions?
And finally, what are recursive objects, and what is the purpose of implementing class and objects in data abstraction?
So let's dive right in. So the first question is just to review the basics of the definition of data abstraction. So what is data abstraction? Data abstraction is the process of simplifying a complex process, and to learn more about the basics in abstraction, please go check out our previous episodes.
Great. Moving on, our next question is: what are the parts of abstract data types? So the use of abstract data types are important because they try to separate conceptual objects and operations from their implementation. In other words, to put it more simply, they separate the interface and the implementation because the user does not necessarily have to know exactly how each and every single part of an object or machine works so that it can be used, which is why the interface and implementation is often separated. So, in our previous episode about abstractions, we talked about the advantages of data abstraction and how they are beneficial to the user because they can be reused, they're easily understood, and they can easily be changed between implementations as well. But another important thing to know about abstraction are the parts to the abstract data types.
So there are two parts to abstract data types. One is the public or external part, which consists of the user's view of what the structure of an object is and what the user can do with it, called the conceptual picture and the conceptual operations, respectively. The other part is the private or internal part, which consists of how the structure is stored, which is the representation, and how algorithms are used, which is the implementation of the operation.
Right. So earlier we mentioned that the conceptual operations and the implementation of the operations, but something important to remember is that there are many possible operations that can be defined for each ADT or abstract data type. And some of the most common include initializing, adding data, access data, and removing data. So, moving on to our next question: what is the sequence abstract data type, and what are the operations? So, the sequence abstract data type is an ordered collection of items in which one is a current item. So, let's talk about some common sets of operations involved with the sequence abstract data type. Size is an operation that returns the number of items in the sequence.
The add before operation is an operation that adds a given item before the given item or at the front of a sequence if there is no current item and making the new item the current item.
Add after is a similar operation, but instead of adding at the beginning or before a current item, this function would add after or at the end of a sequence.
The remove current operation is an operation that removes the current item and it makes the next item in the sequence the current item. But if it is at the end of the sequence, there would be no next current item.
Start is an operation that is a little different from what it sounds like, unlike the other operations, because it makes the first item in a sequence the current item.
The getCurrent operation returns the current item and isCurrent returns true if the current item is present. Otherwise, it would return false.
And advance is a simple operation that simply advances the current item.
And lastly, our final operation is lookup, which is a Boolean expression because it would return true if a given item is in a sequence, otherwise it would return false. So our next question is, what are mutable data abstractions and a mutable set? So Cornell's website was extremely helpful with providing information. So mutable data abstractions are abstractions whose values change over time and are avoided from being used because they are more complicated to work with when compared to a functional data abstraction. There is an advantage to using mutable data abstractions though, and that is because they are capable of solving problems efficiently. So something important about a mutable data abstraction is that the operations should fit into one of the three following operations: observers, creators, or mutators.
So observers are operations that return information without any side effects. Creators are operations that construct new abstract values, but if there are two identical calls to a creator, it will not return the same value. And finally, mutators are operations that change the mutable abstract value in some way. And even though they primarily function as a mutation, sometimes mutators may return information about what has happened as well.
Before we go on to the last next topic for today, let's talk about mutable sets. A mutable set is a set that can be updated to include more elements or to remove some elements.
So our final question for today our final questions are: what are recursive objects, and what is the purpose of implementing class and objects in data abstraction? For this question, composingprograms.com was extremely helpful. So moving on, the answer to the question is that when an object of some class has an attribute value of that same class, it is called a recursive object. And that also further proves that objects can have other objects as attribute values.
And the purpose of the implementation of class and objects in data abstraction is done because class and objects can be represented using functions and dictionaries, and they do not require a specific programming language.
So that's it for today's episode about Amazing Abstractions, Part 3. I hope you guys had a fun time listening to this podcast, and don't forget to tune in to our upcoming episodes. Feel free to reach out through our Instagram page, STEMtime Podcast. Please follow our Facebook, Twitter, Instagram, and YouTube accounts. Don't forget to keep learning new things. See you in the next episode. Bye-bye.
Bye, guys.